So this is part 239, line 22d Syngas Turbine Engine Isotropic Hyperbolic Neutrinos 5G Wow Seti. Just so you know, line 22 goes from A to K at the moment. It could change. All the videos are connected, so if you're looking at this line, you want to start with A, okay? So this is the Wow Seti alien radio signal. And this is the keywords that came up as isotropic neutrinos hyperbolic gas power engine. Okay, so these are the keywords that came up in line 22, and we're just breaking them down to see what comes up with them. Okay, so we further find that a more complex and realistic system of unequal numbers of neutrinos and antineutrinos is analogous to a spinning top subject to a torque. This analogy easily explains how such a system can oscillate in both the bipolar and the synchronized mode, depending on the neutrino density and size of the neutrino-antitrino asymmetry. Our simple model applies strictly only to isotropic neutrino gases. In more general cases, and especially for neutrinos streaming from a supernova core, different modes couple to each other with unequal strength, an effect that can lead to kinematical decoherence in flavor space rather than collective oscillations. The exact circumstances under which collective oscillations occur in non-isotropic medium remain to be understood. So the next thing that comes up is astrophysics, self-induced conversion in dense neutrino gases, pendulum in flavor space. From 2007, there's the name of all the people involved with it. Neutrino-neutrino interactions can lead to collective flavor conversion effects in supernovae. And in the early universe, we demonstrate that the case of bipolar oscillations where a dense gas of neutrinos and antineutrinos in equal numbers completely converts from one flavor to another, even if the mixing angle is small, is equivalent to a pendulum in flavor space. Bipolar flavor conversion corresponds to the swinging of the pendulum, which begins in an unstable upright position, the initial flavor, and passes through momentarily the vertically downward position, the other flavor, in the course of its motion. The time scale to complete one cycle of oscillation depends logarithmically on the vacuum mixing angle. Likewise, the presence of an ordinary medium can be shown analytically to contribute to a logarithmic increase in the bipolar conversion period. We further find that a more complex and realistic system of unequal numbers of neutrinos and antineutrinos is analogous to a spinning top subject to a torque. This analogy easily explains how such a system can oscillate in both the bipolar and the synchronized mode, depending on the neutrino density and the size of the neutrino-antineutrino asymmetry. Our simple model applies strictly only to isotropic neutrino gases. In more general cases, and especially for neutrinos streaming from a supernovae core, different modes couple to each other with unequal strength, an effect that can lead to kinematical decoherence in flavor space rather than collective oscillations. The exact circumstances under which collective oscillations occur in non-isotropic media remain to be understood. Okay? That's from rxv.org. In normal operations, this unit is configured to operate on syngas. Oh, this has got a different, okay, it's the same one. But startup typically is performed on a secondary fuel, such as a natural gas or distillate. When there's not enough volume of syngas to fire the unit at base load, the combustion system can be co-fired with natural gas. The amount of natural gas required will vary depending on the heat content and volume of syngas. The turbine also can operate at a base load on natural gas. The 7F Syngas Turbine utilizes GE's multi-nozzle quiet combustor MNQC, and that's in penenergy.com. June 11th, 2012 at 12:12 p.m. So I googled kinematical decoherence, and up comes the self-induced decoherence in dense neutrino gases from G.G. Raffet and G. Siegley on 2007. Dense neutrino gases exhibit collective oscillations where self-maintained coherence is a characteristic feature. Neutrinos of different energies oscillate with the same frequency. In a non-isotropic gas, however, the flux term of the neutrino-neutrino interaction has the opposite effect of causing kinematical decoherence of neutrinos propagating in different directions, an effect that is at the origin of the multi-angle behavior of neutrinos streaming off a supernovae core. We cast the equations of motion in a form where the role of the flux term is manifest. We study in detail the symmetric case of equal neutrino and antineutrino densities, where the evolution consists of collective pair conversions, bipolar oscillations. A gas of this sort is unstable in that an infinitesimal entropy is enough to trigger a runaway towards flavor equipartition. The self-maintained coherence of a perfectly isotropic gas gives way to self-induced decoherence. Next is the high energy physics phenomenology. And that's rx.org. Okay? June the 11th, 2012, 1:30. My thoughts based on keywords from these PDF files that came up with these ideas. The formula idea is isotropic plus neutrinos plus hyperbolic plus gas power engine plus torque plus oscillate plus isotropic neutrino gases plus kinematical decoherence plus dense neutrino gases plus multi-angular behavior neutrinos. And the next video will be 22E, line 22E.